So this is 4.3, and we're going to be solving the system with different methods, but we'll still do the elimination method too. So take a look at an example. We'll do this. It's 2y equal to negative 6 minus 5x. And we also have 2x equal to negative 5y plus 6. So right away we want to eliminate one of the variables, but notice everything's kind of not organized. And so it'd be good to organize it so that the x's are lined up, the y's are lined up, and then the constants are lined up. So I'm going to add 5x here to both sides. And then I'm also going to add 5y to both sides. So now it looks like this: 5x plus 2y equal to negative 6. And then we have 2x plus 5y equal to 6. Okay, so that kind of organizes it all. So then probably what I like to do, okay, is multiply, since they're both positive. Maybe multiply and get the x's eliminated, because I have not done that yet. So I'm going to multiply the 5x times 2, and then I'm going to multiply the second equation by negative 5. So that's 10x plus 4y equal to negative 12. And then this is negative 10x plus, no, not plus, let's write that up. So negative 10x, and that's minus 25y equal to negative 30. Okay. So now the x's will be eliminated, and so now 4y minus 25y is negative 21y. And then we have negative 30, and we have negative 12, don't we? So that's negative 42. So then we're going to divide by a negative 21. And so then y is 2. So now I'm going to put 2 back into the original equation. So that's 5x plus 2 times 2 equal to negative 6. Right? That's this one I'm doing right here. This 5x minus 2y. Okay? So that gives me 5x plus 4 equal to negative 6. Right? And then I can subtract 4 from both sides, and so that gives me negative 10, and then divide by 5, which x is 2. So I now know my point of intersection is negative 2, 2. So I could also graph these two equations. So when I did that, I had one equation that was 2y equal to negative 6 minus 5x, right? That was what my equation looked like. So if I want to put that in slope-intercept form, I'll just go ahead and divide everything by 2. So I get y equal to negative 3 minus 5 halves x. And so that's my first equation. The second one, we'll move the 6 over. So it's actually what the equation was given to me as 2x equal to negative 5y plus 6. So I'm going to minus 6 from both sides to get the negative 5y equal to 2x minus 6. Now I'll divide by negative 5. And so now I'm going to get y equal to negative 2/5 x. And then this is plus. So plus 6/5. Is that right? So let's see that. Okay. Yeah, that's right. So yeah, so I get the 2x. So I divide by negative 5. Okay, so here's my second equation. So let's go ahead and let's graph that. Alright, so I'm going to clear, I'm going to go to y equals, clear these two equations out. Okay, put the first one in, which was, where did I put it? It was here, right? Here it is right here. Here's the first one. So negative 3 minus 5 divided by 2x. Okay, and then my second equation is negative 2/5, right? And that was x, and that's plus 6/5. Okay. Alright, so now I'm going to go ahead and do zoom 6. So here are the two equations. Okay. And if I go to second calc, I can do 5 for intersection. And there's my solution, negative 2, 2, just like I got here to find doing the elimination method. Okay. So that tells me that that worked. I can also see it in the table. I can hit second calc or second table, and I'll go to my x value of negative 2, and there it is. I get both y values for 2. So I'm able to show numerically and through a table and through the graph that my solution does work. It's negative 2, 2 for all that. So these are just 3 different ways of looking at a system of equation and being able to solve for its solution.